German engineers examined a captured B-29, then admitted they were a decade behind in aviation technology. November 5th, 1944, near Kassel, Germany. The air raid siren was the first sound, a rising and falling wail that cut through the evening quiet. Then came a deeper, more menacing sound, the drone of four massive engines at an altitude so high the aircraft was barely visible. A tiny silver cross against the deep blue of the upper atmosphere. For the citizens of Kassel, it was just another lone reconnaissance aircraft, a nuisance. But for Oberleutnant Klaus Richter of the 44th Fighter Wing, vectored to intercept from his airfield 60 miles to the east, this was different. The radar returns were unlike anything he had seen. The target was flying at over 32,000 feet, and it was enormous. Richter, in his Focke-Wulf 190D9, pushed his aircraft to its absolute limit, the BMW 801 engine screaming as he climbed. The thin, cold air at 30,000 feet made his fighter feel sluggish. He could see the American aircraft now, a giant with the impossibly long, sleek wing and four distant, powerful engines. It was a Boeing B-29 Superfortress, a ghost, a weapon they had only heard about in intelligence briefings and seen in grainy photographs. It shouldn't be here, over the heart of the Reich. As he closed, defensive fire erupted, not from the familiar .50 caliber positions of a B-17, but from remotely controlled, computer-aimed turrets that tracked his approach with terrifying precision. He fired his cannons, saw pieces fly off a wing, but then his own aircraft shuddered violently. A shell from the bomber's tail gun had found its mark. With his engine streaming smoke, Richter was forced to break off and bail out. The damaged B-17, its mission to photograph the devastated Henschel tank works complete, turned for home. The B-29, however, named Wandering Lady, and from the 462nd Bomb Group, had taken a critical hit in its number 2 engine. Losing fuel and power, it began a slow, inevitable descent away from the safety of its formation. The pilot, Captain James Miller, knew they wouldn't make it back to their base in England. "Prepare for emergency landing," he ordered, his voice tight over the intercom. He aimed for what looked like a flat field west of the bombed-out city. The landing was brutal, a controlled crash that tore off the landing gear and carved a furrow a quarter-mile long in the German soil. But the fuselage and its technological secrets remained largely intact. For the crew, the war was over. They were quickly captured by local Volkssturm militia. But for the Luftwaffe, the war had just taken a stunning turn. They had captured the single most advanced bomber in the world. The news reached the Luftwaffe's technical office in Berlin within hours. General Stab's Ingenieur Ernst Zobel, a veteran aircraft designer who had worked on everything from the Ju-88 to the nascent Me-2 62 jet, received the message with a mixture of disbelief and exhilaration. He immediately dispatched a special recovery team from the Circus Rosarius, the same unit that handled other captured Allied aircraft, with one overriding order: secure the site and protect the aircraft at all costs. This was not merely another war prize. It was a technological Rosetta Stone. What the German recovery team found when they arrived at the crash site near the village of Bad Orelsen left them in a state of profound shock. The B-29 was not just an evolution of previous bombers, it was a revolution. The first thing that struck them was the sheer scale. The B-29 dwarfed the German workhorse, the Heinkel He-1111, and even the newer Junkers Ju 388. Its 141-foot wingspan was longer than that of any German bomber, and its fuselage was a vast, pressurized tube. But it wasn't the size that was truly revolutionary, it was the details. The skin of the aircraft was smooth, almost seamless. German engineers who prided themselves on precision ran their hands over the flush-riveted surface, a technique that reduced drag to a degree they had only theorized. The wings were massive, not just for lift, but housing integral fuel tanks of a capacity that seemed impossible. Most startling of all were the gun turrets. There were no gunners visibly manning them. Instead, they were controlled remotely. Small armored plexiglass blisters around the fuselage housed the sights, and the gunners, deep within the pressurized safety of the cabin, aimed and fired using a sophisticated analog computer system. "This is not an aircraft," one of the junior engineers was heard to mutter. "This is a flying laboratory." The recovery operation, codenamed Unternehmen Geschenk, Operation Gift, was a monumental logistical undertaking. The B-29 was carefully disassembled by a team of over 100 technicians and engineers working round the clock under heavy guard. Every component, from the smallest electrical relay to one of the massive 18-cylinder Wright R3350 duplex Cyclone engines, was catalogued, photographed, and crated for transport on a special train to the Luftwaffe's primary test and evaluation center at Rechlin. The journey to Rechlin was a nerve-wracking affair. Allied air superiority meant the train had to move mostly at night, its precious cargo hidden under tarps. But it arrived intact. At Rechlin, the B-29, now designated with the German capture code FE4600, Foreign Equipment 4600, was reassembled inside a massive camouflaged hangar. The best minds of the German aviation industry were summoned. Engineers from Junkers, Heinkel, Focke-Wulf, and Messerschmitt, as well as senior officers from the Luftwaffe High Command. The systematic dissection began. What they discovered systematically dismantled their confidence in German technical superiority. The revelation of pressurization. The concept of a pressurized cabin for a combat aircraft was something German engineers had considered but deemed too complex and heavy for practical application. They had pressurized the Ju 388, but it was a cramped, limited system. The B-29's cabin was a different world. It was a large, comfortable environment for an 11-man crew, allowing them to work efficiently in shirt sleeves at 30,000 feet, while outside, the temperature was minus 50 degrees Fahrenheit and the air too thin to breathe. The system was elegantly simple and robust, using the engine turbo superchargers to supply pressurized air. Professor Heinrich Hertel, a leading designer from Junkers, examined the system and reportedly told his team, "We have been thinking about this problem backwards." The Americans did not see it as a luxury, but as a necessity for strategic effectiveness. Our crews are exhausted from the cold and hypoxia after a few hours. Theirs are fresh. This alone is a force multiplier we cannot match. The Central Fire Control System. This was the technology that truly bordered on science fiction for the Germans. The B-29's gunnery system, designed by General Electric, used analog computers to automatically calculate lead and trajectory for the remote turrets. A gunner in the rear station could control the two aft turrets simultaneously, the computer ensuring the guns would not fire if they were pointed at a part of their own aircraft. Engineers from Siemens and Telefunken, the masters of German electronics, spent weeks reverse engineering the system. They found it used a network of synchronizers, amplifiers, and servo motors of a reliability and miniaturization they struggled to comprehend. "We can build something similar," one Telefunken engineer confessed in a classified report. "But it would be twice the size, half as reliable, and we could never produce it in quantity." The Americans have not just invented a new weapon, they have invented a new way of building weapons. The power plant puzzle. The Reich R3350 engines were a masterpiece of mechanical engineering that both impressed and horrified the Germans. Each engine produced 2,200 horsepower, far more than any German radial engine in service. But it was the details that stunned them. The intricate cooling system for the rear rows of cylinders, the sophisticated turbo superchargers that maintained power at high altitude, and the use of lightweight alloys that German industry, starved of strategic materials like magnesium and high-grade aluminum, could no longer afford. Dr. Franz Neugebauer, the head of engine development at BMW, wrote a sobering assessment. The R3350 represents a level of specific output and thermal efficiency that is at least 5 years ahead of our own piston engine technology. Its complexity is breathtaking, yet the Americans are producing them by the thousands. We must abandon the hope of catching up in piston engine design. Our future, if we have one, lies solely with the jet engine. The industrial reality. As the analysis continued, a more profound and depressing realization set in. It wasn't just that the B-29 was technologically superior, it was that it was manufacturably superior. The aircraft was designed for mass production on a scale the Germans could barely imagine. The standardization of parts, the modular construction, the use of sub-assemblies built by different contractors, all spoke of an industrial ecosystem of immense power and coordination. A junior engineer, tasked with cataloging the electrical wiring, made a note that became infamous among the Rechlin team. The quality and consistency of the copper wiring and insulation is superior to anything currently available in the Reich. They have better wire. The ultimate humiliation came when the Germans decided they would attempt to copy the B-29. In early 1945, with the war situation deteriorating rapidly, the desperate decision was made. The aircraft would be reverse-engineered and put into production as the Junkers Ju 390. A team was assembled, blueprints were drawn from measurements of the captured aircraft, and components were allocated. The project was a catastrophic failure, and it revealed the true depth of the German technological gap. They could not source aluminum of the required quality and consistency for the large stress skin panels. Their attempts to replicate the flush riveting resulted in weak points and structural failures. The sophisticated electronics of the fire control system proved impossible to reproduce with German vacuum tube technology and available materials. When they tried to test fly a German-built wing section, it failed at stresses the original B-29 wing handled with ease. The most telling moment came when they attempted to replicate the R-3350 engine. German engine factories, damaged by bombing and crippled by material shortages, could not produce the high-precision forgings and specialized alloys. A prototype engine, built using substitute materials and rushed craftsmanship, seized and destroyed itself on the test stand after running for less than an hour. In a final, secret meeting of the Reich's Luftwaffe Ministerium, Reich Aviation Ministry, in March 1945, General Stabs Engineer Zobel was forced to deliver the final report on the B-29 analysis and the failed Ju-390 project. The room was filled with the men who had designed the aircraft that had terrorized Europe. They were silent as Zobel delivered his conclusion. "We have examined this aircraft for 6 months," he said, his voice flat and exhausted. "We have taken it apart bolt by bolt, wire by wire. We must confront a truth we have avoided. This is not a matter of 1 or 2 clever innovations. This is a matter of systemic, national capability. The Americans have not just built a better bomber, they have built a better system for building bombers. Their mastery of mass production, their access to strategic materials, their advancements in aerodynamics, electronics, and propulsion represent a cohesive technological advantage of at least 10 years. We cannot copy this aircraft. We cannot build it. The industrial and scientific foundation required simply no longer exists in Germany, if it ever did." He paused, looking at the faces of his defeated colleagues. "Gentlemen," he concluded, "we are not fighting the army of another nation. We are fighting the inevitable future, and it has arrived 10 years too early for us." The captured B-29, FE-4600, sat in its hangar at Rechlin until the end of the war. It was never flown by the Germans. When American troops overran the base in May 1945, they found it exactly where it had been reassembled, a silent, gleaming monument to a technological superiority that had helped decide the war not on the battlefield, but in the factories and laboratories of a nation the Third Reich had profoundly underestimated. For the German engineers who had studied it, the B-29 was the definitive proof that the war had been lost long before the first Soviet soldier raised the red flag over the Reichstag. The psychological impact on the German engineers and test pilots was profound and immediate. For men who had been raised on a doctrine of German technological superiority, the B-29 was not just an aircraft, it was a cognitive rupture. Test pilot Hauptmann Erich "Booby" Hartmann, the world's leading fighter ace, was brought to Rechlin to provide a tactical assessment. After a detailed briefing and a walk-around of the colossal bomber, he was uncharacteristically quiet. He later confided to a fellow pilot, "Looking at that aircraft, I did not see a machine. I saw the entire American war economy distilled into one silver form. We have been shooting at the symptoms. This is the disease. How do you fight a nation that can build this?" The analysis extended beyond the airframe to the very philosophy of its design. German engineers, trained in a tradition that prized mechanical complexity and individual craftsmanship were baffled by the American emphasis on maintenance, accessibility, and component standardization. They found that entire sections of the wing could be unbolted and replaced in the field. Electrical connectors were uniform and color-coded. Hydraulic lines used quick disconnect couplings. A senior Junkers designer, Dr. Werner von Braun's propulsion specialist, noted in his journal, "Their genius is not in making it complex, but in making complex systems simple to service." Our philosophy is to build a masterpiece that requires a master to repair. Theirs is to build a masterpiece that any mechanic can fix with a standard toolkit. In a war of attrition, their philosophy is victorious by default. The discovery of the B-29's advanced navigation and bombing systems delivered another blow to German morale. The aircraft was equipped with the AN/APQ-13 radar bombing system, which allowed for target acquisition through cloud cover and at night. When German radar experts from the Telefunken company examined it, they found it used a klystron power amplifier, a technology they were still developing in laboratory settings. The realization that this advanced radar was already in mass production and being used operationally by thousands of American crewmen was a demoralizing shock. It meant that the strategic bombing campaign, which already had a 10-to-1 quantitative advantage, now possessed a qualitative advantage that made German air defenses, which relied on visual interception and primitive radar-directed flak, effectively obsolete.